Okay guys, last in the series of 3 of operations with surds. Operation surd. Multiplying and dividing. Let's go and conquer. When multiplying and dividing surds, well, what do? We simplify them as much as possible. Well, I do anyway. I think that's the best way to go. Before I do anything. Then I multiply and divide inside and outside the square root sign or the cube root sign or whatever it is sign separately. And then we simplify again if we need to inside the square root sign if necessary, or anywhere else that looks like it needs cleaning up again, because sometimes you need an extra simplification after you've actually done the dividing and the multiplying. Okay, I'll show you an example of that as we go. Here are some examples for us. Well, look at that. 6 root 12 times 3 root 6. And second one is 2 root 5 times 3 root 5. Third one is root 13 times root 5, and that one is, well, that looks pretty awful. 12 root 88 over 3 root 99, and then there's two more. There's root 65 over root 5, and then we've got a beastly looking catastrophe there for us to finish off with a bang. However, they will all give up without a fight when we assault them with our deadly surd weapons, okay? Number A. Today, let's simplify. Now, come on, we're going to simplify what's under the surd thingies. We know that that's really, the first term is 6 times, now 12 is 2 times 2 times 3. They're the prime factors of 12, yes? Times 3, that's the outside, the bracket bit there, right? And then you know that 6 is 2 times 3, yes? They're the prime factors. Now this one here, look, which one gets out of jail there? There's a pair of them, look, a pigeon pair of 2's. So that's 2 squared. That gets out of jail as just a nice, happy little liberated 2 and leaves the poor old 3 stuck in there, yeah? And now we're going to multiply that by 3 times the rest of it, yeah? Root 2 times root 3. Now, what we can do now is we can combine all the numbers together. That's the 6 times the 2 times the 3. And then we can combine all those separate surds into one large umbrella surd, because that's the way surd maths works. You can do that. The same thing with dividing as well, as we'll see in a moment. So now look. You look at this, guys. You see now, I've got 3 times 2 times 3. Now, that's what I was saying up there. You might need to simplify again inside the square root sign, or the cube root sign, or just the surd sign, if necessary. See, and this is a perfect example of that. We've now got a pigeon pair of 3's in there, and they can get out of surd jail, you see? And we're just left with the root 2 in there. So that's how you do it, you see? And that's going to be 108 root 2, and we've done it. Isn't it good? Now, you knew that, didn't you? Well, if you didn't, you know it now. So that's pretty good. Let's do B. B is 2 root 5 times 3 root 5. Now, look at that. If we, basically, there's no simplifying there because 5's are just prime numbers anyway, right? So you can't simplify under the surd into any more prime factors because they're already prime factors. So what we get is we combine the two numbers, we do the multiplying, and we combine the two surd numbers, and what do you get? 6 root 25. Now, this is another case of where you have to simplify after you've done the multiplication, because those 5's, they get out of jail. There's a pigeon pair of them, right? So it's 6 times 5, and you get 30, and that's the answer. No surds anywhere. That's actually just a number. Yeah? Terrific. Let's do C. That looks like root 13 times root 5. Well, both of them are prime numbers, so you can't simplify them any further. No other factors. So we'll just multiply them together under the big umbrella surd, and you get basically, what's 5 13's? Well, it's 65. To keep us alive and make us thrive, that's the answer. Yes? Isn't it great? Now, what are we up to? Well, this one looks a bit beastly. It's a dividing one, so let's attack that one. First of all, we're going to simplify. Let's simplify first. So that root 88... now, come on, what's 88? Can you do it? Can you do it in your head? Well, it's 11 times, and of course the 11 times 8, the 8 is 2 times 2 times 2. So it's basically 12 times square root of 11 times 2 times 2 times 2. Now, over 3 times, same thing with 99, but only it's 11 times 9, which is 11 times 3 times 3. Now, what do you think we should do now? Well, I would be inclined to simplify the top and simplify the bottom, get all the little beasties out of surd jail that can get out, and then you know, we can fix up the end bit at the end. So the 2's got out of surd jail on the top, and the 3's got out of surd jail on the bottom, didn't they? And that's the rest of the bottom there, okay, just a root 11. Now, what we can do now is go over the page, and we can basically do a big umbrella divide, okay, of that dividing stuff there. So let's go over and see where we got to. That's, oh, well, wait a minute. This is where we got to. We got to here. Yes, we got to there. Now we're going to divide, and yes, that's right. So, see, what I've done there is I've put a big umbrella to divide this by this under the same common surd sign. And you can see what's going to happen, can't you? Yes, you can. Yes, you can. And there's going to be some cancellarumi happening out here. Cancellarama, I mean. Because 3 is going to go into 12 4 times, isn't it? So let's do that. That's that one. And the 11s go, and they cancel each other out. So what are we left with after this amazing spectacular? We got 4 times 2 on the numerator up here. That's 4 times 2. We've got just a 3 left there. And from in here, we've just got the 2 left. So that's interesting, isn't it? So therefore, you can call it 8 root 2, because the root 2 is on the numerator. 8 root 2 over 3, and that's going to be our answer. Yeah? Wasn't that good? Of course it was terrific. Now here comes E for you and me. Okay, simplify first. Well, 65. What's that? Oh, that's 5 times 13, isn't it? 5 times 13. So they're both primes, so they won't simplify anymore. I think we just what we're going to do now is the big umbrella divide. Yes, there. Yeah, that's right. No other factors, prime numbers. Do the dividing now, and what do? We get to that, and we're going to cancel those 5s, and that's just going to simply get us root 13. Good heavens, will wonders never cease? Right, now what are we doing now with F? F was the catastrophe one, wasn't it? Oh dear. Oh, here we go. Yuck! Never mind, we can sort it out. We'll just use the same rules that we've used for everything. First of all, I think we should simplify the top. And that looks, yes, 5 squared, because you know 25 is 5 squared, don't you? Times x times y. And the bottom line is the 6 squared is 36 times x to the 9, y to the 11th. Ugh. Well, come on, we'll get the beasties out of surd jail first, the numbers out first, right? 5 over 6, that's good. Now, okay, that makes sense, yes. Let's put it under now the big surd umbrella, right? There we go. Now that's looking a lot nicer now. Now you know what to do. You know what to do under that surd umbrella, don't you? You cancel the top and the bottom, don't you? The battle of the top and the bottom. So here we go. That's going to go completely gone, and that's 9 is going to turn to an 8, because you've got x to the 1 on the top cancels one of the x of the 9 x's on the bottom and leaves 8 of them, doesn't it? Yes. Now, what about the y's? Same deal, guys. That y on the top will cancel one of the y's on the bottom and leave 10 of them. Now, I think we're nearly done now. Oh, we're not quite done. There. Now, look, we've got 5 on the top, 6 on the bottom, and then a square root. No more square root on the top left at all, because that just left 1s, and the square root of 1 is 1. So what are we left under that square root sign? We're left with x to the 8, y to the 10. Now, look, you do know that x to the 8 is x to the something squared. Because I want to get the squares, so I can get the squares out of square root jail. And y to the 10 is y squared to the something, isn't it? Or, no, hang on, it's y something, y to the something squared. That's what I'm trying to say. I'm going boggle-eyed here. Right? Do you get it? Look, I'll show you. See, it's 5 over 6 times the square root of x to the 4 squared times y to the 5th squared. You see, I want them squared. You know that works from your index laws, because you learnt that recently, didn't you? You know how you multiply these little beasties together when you've got a power raised to a power? Well, I just went sort of backwards. Instead of doing this and getting to there, I kind of engineered it backwards. So going from the already multiplied out bracket to putting the bracket in. All right? But now the beauty of this is you can see what's going to get out of square root jail, can't you? because it's x to the 4 times x to the 4. And this is y to the 5 times y to the 5. So what's going to happen? You have a look. Yes, you're going to make a prediction? Well, it's going to be x to the 4. And this one's going to be y to the 5. And there's no square root signs anywhere in sight. There she be. Okay? Put a box around it and everything's beautiful. And we know how to do multiplication and division of surds. And you are a star, of course. Now, you need to go and do plenty of practice to get good at this and do as well as you can in the test, okay? All right, all the best, and it's been lovely spending some time with you, and we'll see you later. Bye-bye.